this I need 2 of those, and so thus I need 2 electrons there. Is that part okay? So it's mostly going from words to the reaction. They give me the potential for this. I do that, I have to do that whenever it's not in the table in the back. Okay, then it tells me standard hydrogen electrode. So this one's a reduction so far. We'll see if we switch that or not. Then you go to the standard hydrogen electrode. If you totally blink on the exam, just go to the table. It's listed in there. You just have to know it's the one that's 0. So it's this one right here. Okay. Yes?
The 2 by the mercury.
Oh, and a 2 here. Good. Standard hydrogen electrode. I'll just copy it down as is. We'll figure out later if I need to flop it around. Okay. E0. That's why it's a standard hydrogen electrode. It's our standard, literally. Okay, now, what page did I say it was on? 24. Lost it. Okay. Now, write the reduction half reaction. Okay, so let's decide which one is the reduction half reaction. So which one, if this is spontaneous, which it is, it doesn't say anything about electrolysis in here. It doesn't say anything about non-spontaneity or battery. So I'm assuming it's spontaneous, which is normally true. Normally going to be the case, I should say. Which one do I flip, top or bottom? Yeah, so this is actually going to be the reduction. I'm going to have to flip this one to make it the oxidation. Okay, so I'll just write flip for now. We know it's going to be flipped. All right, so the reduction half reaction answer to A is this. Now, using the standard hydrogen electrode, which we already did, find the cell potential. I flip this. The cell, the whole cell is going to be 0. Okay? So that's B. C, now we get into some craziness here. You got a pressure, you got a pH. When you see pH, why is the cell 0?
Shouldn't it be point, yeah.
Huh?
Why is the whole cell 0?
Oh. Because I was delirious. Okay, cool. Okay. When you see pH, think H+ concentration in this class for sure. If it was like outside of this or a final for all of chemistry, you have to say, okay, where does it fit? But that's a possibility. So you think H+ concentration, you got that. You got the measured voltage. Okay, the measured voltage can't be that because you already know what that number is, and this number doesn't change. So that's just the E, squiggly, no standard. Okay, so that'll have to be measured voltage, or it'll just tell you the voltage or something like that. Okay, and then it gives you, it wants to know the chloride ion concentration. So that's the Nernst. I would get it from the back of the test, but let's see if I can kind of remember what it is. I don't know, 2, 5, 6, something like this. Is that kind of right? I think that's it. Oh, divided by n, thank you. Okay, so I've got the 0.27, I've got the 0.77, that's given. And let's go back up to our reaction. This and this is going to be flipped, but n would be 2, because I have a 2, they cancel with another 2. 2. So Q is really the tough part of this one. Q, really I need the whole reaction, so let me write the whole reaction out. So I'm going to flip this and add them. And I'll write that down here. Let's do a different color. Just a little change. Hg2Cl2, that's a solid, plus H2 gas goes to 2 mercuries, liquid, plus 2 Cl's, aqueous, plus 2H+, right? Aqueous. Okay, if I got that all right, then I plug into my Nernst. So really, I'm going to focus on Q for a moment. Products, don't do the liquid, don't do the solid. Okay. Okay, products, Cl, that's the one I'm going to solve for eventually. H+, this is the one connected to pH. We'll look at that in a second. And then, notice this one is a gas. in Chem 2B, you changed everything either to concentrations or to pressures when you put it into Q or K. You actually don't have to worry about that here. You just put them in as is because technically they're activities. So, harsh pressure ratio, you just put it in as is. All right. This typically, just to spike the problem, when it's mixed up, we typically, and there's a 1 pressure in there, we typically just tell you it's 1 atmosphere. So it drops out, which is what I did. It's the way that I spike the problem to make it work, mathematically. Okay. So that one is there. This one's the one we're looking for. And this one, let's go down here. Remember, pH is 4. And you have to remember that's the negative log of the H plus concentration. So H plus, where it's base 10 log, so 10 to the negative 4. And that number is going to go in for H plus. Is that okay? So you need to, if I could kind of rewind just a little bit. I'm going to rewind a little more. You need to plug all those numbers in and basically solve for Cl minus. So see if you can get the answer that whatever it is, it says in the answer key. That is definitely worth it. Calculator practice before tomorrow. And then the last part, the cell diagram. This is a really crazy, you're not going to get a cell diagram even close to as crazy as this, but I'll draw it out anyways for fun. You still want me to, I assume. Shorthand or longhand? What are you looking for? Longhand. So draw the template. Write salt bridge. Put the voltmeter. You can either put the number in here or the letter B, whatever. This is the anode, right? Anode here, right? Cathode here. Okay. You can write oxidation, reduction. So since the left-hand side's oxidation, I know that's the standard hydrogen electrode. So let me take a look at your notes. For that reaction, it's H2 goes to N as reactants, and H plus is a product. There's no metal given, so I'm just going to call this platinum solid. And I'll write the rest in green. So H2 has to go in. It's a gas. Typically the way we do that is you just draw an arrow going in. You can write the word bubble, meaning it's just a way to say there's a tube going into the liquid, putting gas in there. And then off, that's going to react with the platinum. Off the platinum will come the H plus. The electron, oh yeah, I forgot that. The electrons go around this way. Okay, so the electron is also part of the products as well. Okay, that's that side. Salt bridge, let's see if they gave me a salt bridge. They don't. So you could go KNO3 or something like that. I think in the answer key I put KCl. I would have accepted either as a salt bridge. Over here now here's we get a little crazy on the other side. Let's see where that reaction is. We've got a solid, but it's ionic. An ionic can't be electrode. Okay? So we've got the metal there, that can be an electrode because it's ionic. You need something that can actually form shape. When it's ionic, think like table salt. You can't form it into a bar, per se. Okay. That would be a great electrode, except it's a liquid. You need a solid, so that's a little confusing. And that can't be the electrode, it's not a metal. Okay, so what happens here, which you don't really see anywhere else because mercury is the only liquid metal. So that's why this is the only time you would see this kind of scenario. You're basically just going to take the wire and dip it into liquid mercury down here at the bottom. It's at least the way we represent it as the best. Okay. Yeah.
Would it matter whether you put the mercury or the solid first in the order?
It does matter now because I told you in class which order you put it in. And I told you mercury is extremely dense. So because of that, liquid I mean mercury.
It's more dense than the solid would be?
Yeah, it's super dense.
Question.
Yes.
What was your equation? Use 0.592 or 0.0256.
How do you know? That's a great question. How do you know? Let me finish this.
All right.
And then we'll tackle that. Solid, and then the aqueous would of course be on top. That's like the liquid, normal liquids, like water. And this would be in water. Okay. I didn't care anything about the arrows here. It's just a little too crazy. And I forgot. I believe on the exam I'm not grading arrows for the salt bridge, but you'd have to have the anion going this way and the cation going this way. Yeah. Mostly interested, I guess I should say this because I can't say what's on. If there's this longhand notation, I want these kind of arrows typically. This is just a weird one, but I'm typically looking for these kind of arrows there. Okay?
Perfect, thank you.
Okay, and then I'll get to your question in a minute. Yes?
Well, can you explain why the arrow to the H plus is going out and not?
Yeah, the arrow for the H plus has to go out because remember this equation is flipped. This is a product. This is going away from the platinum. Where the platinum is where the reaction is occurring. Okay, now there was another question about the equation. And then I'll get to the next other question. Somebody asked about the equation here. Okay, how do you know which number to use? That number or that number? What do you think?
Doesn't matter. No, that's good.
Doesn't totally matter. What changes though? Yeah, if you use this number here, then that's natural log. If you use this number here, then it's base 10 log. That's it. Whatever number you like is totally cool with me. Okay, yes?
And just for the galvanic cell, just as for electrolysis, you just switch it, right? The cathode and anode. If
That
you
you need
add-
electrolysis. So this was the galvanic.
Yeah, so.
Electrolysis, you switch the cathode to anode, so you totally flop the diagram over. And then you put a battery where the voltmeter is.
And then everything else is still the same.
Yep, everything else is still the same. You have to make sure you got the flow of electrons going in the right direction, but yeah, it should all be the same. Yes? Why isn't the basically the mercury 1 chloride, why isn't that the electrode? That's your question? Really, you want the electrode to be the metal. Okay? This is a salt. Think of like table salt when you eat dinner. You need to form this thing into a bar in order to be an electrode. And salts or ionics tend to not be good electrodes. They don't hold together all the time. So you always prefer the metal if there is one. So if this was a solid, I would have put a bar right here and put mercury. But it's not a solid, it's a liquid. It's the only time it'll ever happen because it's the only one that is a liquid. I just have to lay it at the bottom. But if it was a bar, if it was a solid, I would have made a bar right there like that and put mercury here.
So even though it says solid,
Even though it says solid, it has to be a metal. Or the only other solid that's a non-metal that we use in our class at least is carbon graphite. But again, it's carbon all by itself. And in lab, I think often you use graphite electrodes when you're doing not pH, but voltage readings. Okay, other questions on this, and then I'll kind of excuse you, and we'll see if there's anything else going on. Yes?
So we have to list what stage is in a solution like that.
Oh yeah, here, for sure, I always want to know the state symbols. Always on this. Reactions for main group and that sort of stuff, I don't need to know it, but here for sure. All the state symbols.
And also for electrolysis, we do include the electron flow as well.
For electrolysis, you're flipping both reactions, so the electrons would be going the other direction, if that makes sense. Yeah, so it's kind of, really the whole diagram is flipped. Yeah. Yes?
I have an electrolysis problem. Can we possibly go over it?
Yeah, hold up, let me see if there's anything else on this. Yes? Shorthand. Yeah, that's a good question. The shorthand would be left-hand side solid. Let's see. Gas. Oops. Oh, ugly. Okay, gas. Let's see what else there is. Aqueous. This one's a little messy because traditionally we go aqueous, gas, liquid, solid. So doing that, you wouldn't put the electrode on the end. I would be totally fine if you flopped these two, just because in this, again, this is a really rare scenario. I would be okay on this test if these two are flopped. That'd be fine. Okay. All right, here's what I'm gonna do. I'll try that electrolysis problem you found. Anybody who wants to leave is fine. After I do that, if there's people who have more questions, the only chance that I have to getting this review on tonight is if I go back to my office, so you can follow me there if you have more questions after we do electrolysis. Sound good? Okay, the rest of you want to leave, that's totally fine. This will be our last talk in this room. Okay, where did you find this? Oh, from me? Oh, okay. Oh, yeah. Do you know what test this is? So I can tell everybody. Oh, recent. Oh, can I keep both? Let's see.